Alright, this is the best I can do at this point. It's just a PDF. So we know that the energy equation equals the change in energy. The change in energy equals Q plus shaft work minus the change in enthalpy minus the potential, and the change in potential energy minus the change in kinetic energy. Now, steady system, change in energy equals 0, adiabatic, Q equals 0, and the change in potential energy equals 0 because it's a straight pipe. Change in kinetic energy, we assume that's negligible, so that's 0. Hence, the shaft work minus the change in enthalpy equals 0, and the shaft work equals the change in enthalpy. Now, from the shaft work equals volumetric flow multiplied by the change in pressure, the derivative of that with respect to P2 over P1, and the change in enthalpy is the derivative of molar flow rate multiplied by constant volume heat capacity with respect to change in temperature between T2 and T1. Really difficult reading an equation. So using the first method, we know that we can set these two equations to equate each other. So the volumetric flow rate with respect to change in pressure equals the molar flow rate multiplied by CV with respect to change in temperature. Now, these two integrals can only be identical if all of P1 and P2 for all of P1 and P2. So you can set these integrals to equate. Hence, with respect to between P2 and P1, VdP equals NCP dt over dP with respect to change in pressure. And P2 equals P with respect to temperature 2, and P1 equals P with respect to temperature 1. So, this can be reduced to the volumetric flow rate equals NCP dt over dP with respect to change in pressure. And we know V equals nRT over P. So nRT over P equals NCP dt over dP with respect to pressure. And RT over P equals CP dt over dP with respect to change in pressure. So if you integrate that equation, you get R over CPP multiplied by P, and with respect to change in pressure equals 1 over T dt over dP with respect to change in pressure. Yeah, following the maths is simple. It's just you also need to put the actual parameters into your equation. So it's all ideal gas flow. So for ideal gas, heat capacity is pressure independent rather. So R over Cp multiplied by P with respect to change in pressure equals 1 over T with respect to temperature, change in temperature between P2 and P1 and T2 and T1. So the logarithm, so they are a monotonous function. So R over Cp log of P2 over P1 equals log of T2 over T1. So math is simple again. Now, for adiabatic expansion, P2 over P1 to the power R over Cp. Remember your log laws equals T2 over T1, and T2 over T1 equals P2 over P1 to the power gamma minus 1 over gamma. Remember you're substituting for R over Cp. R equals Cp minus Cv, Cp minus Cv. Method 2, using differential form. The shaft work equals the change in enthalpy, we know that. The change in shaft work equals the change in enthalpy. And we know shaft work is VdP and enthalpy is NCP dt. And we know V equals nRT over P. So nRT over P multiplied by, with respect to change in pressure equals NCP dt, and R over CP, CP times pressure with respect to change in pressure equals 1 over T dt. Remember what happened to NCP. So integrating that, you get the following. You get the following. So T2 over T1 equals P2 over P1 gamma minus 1 over gamma. So try to go through that yourself and learn the maths. That will not come in the exam. So continue. If to determine T with respect to changing T with respect to volume, P1 over V1 T1 equals P2 over V2 over T2. That goes on to become P2 over P1 equals T2 over V1 T1 over V2. Now, if you eliminate the pressure ratio, you get T2 over T1 equals T2 V1 over T1 V2 to the power gamma minus 1 over gamma. And T2 over T1 gamma to the power gamma over gamma minus 1, T2 over T1 to the power negative 1, to swap over, equals V1 over V2. And V1 over V2 equals T2 over T1, 1 over gamma minus 1. You've seen that before. And Vt to the power 1 over gamma equals a constant. And T2 over T1 equals to V1 over V2 to the power gamma minus 1. Which goes on to become Tv gamma minus to the power gamma minus 1 equals a constant. Otherwise, the whole thing is known as a lullaby, apparently. Again, continuing, actually that's a repetition of the previous. And to determine P equals P with respect to volume, T2 over T1 equals P2 over P1. Remember this. You've actually driven these before. To the power gamma minus 1 over gamma, T2 over T1 equals V1 over V2 to the power gamma minus 1. By the way, P2 over P1 to the power gamma minus 1 over gamma, it's not actually delta, it's rather delta, equals V1 over V2 to the power gamma minus 1. And P2 over P1 equals V1 over V2 to the power gamma PV to the power gamma constant. V1 over V2 equals P2 over P1 to the power 1 over gamma Vp to the power 1 over gamma. This was in the open course and the open systems as well. Now, the real question.